Welcome friends, we are into 32nd module of AI, and in this particular module we will be talking about expert systems. Expert systems are something which mimics human experts. For example, doctor, a system which represents or acts like a doctor is an example of an expert system. A system which represents for example, a security expert which looks at what is happening in the computer system and determines whether there is an intrusion taking place or not, an example of an expert system. One more program which looks at your investment profile and suggests you is again an example of an expert system. So, basically something which mimics an expert is an expert system, and we will be discussing about the expert system in few modules from here. We will be beginning with the introduction to expert system and the components involved in the expert system and challenges and so forth, so on and so forth during this journey. The difference between other AI problems and the expert system is that other AI problems tend to address any job that people do. Seemingly simple mundane jobs are pretty hard to code, that we have already seen. For example, even brushing a teeth is pretty hard. Compared to that, seemingly harder problems for us, for example, diagnosing a disease is easier to code, maybe surprising, but it is the fact. In fact, according to some researchers, this thing is possibly the most successful part of the complete AI domain. Okay. So, why it is so? Obviously, the reason is that however hard it looks like, it is quite structured. For example, diagnosing a disease, you have rules, what kind of disease, what are the symptoms of those disease, and what are the drugs, and how to derive to a disease. You have thumb rules ready from those experts, and so you can actually code that because it is already available. The question is how to code and how to put it into practice. That's the only thing required, unlike the mundane task where nobody knows how have you recognized your friend after 10 years and so on and so forth. So, here it's that is why it is little more structured, and that is why it is possible to be done here. Okay. There are two different types of expert systems. One is a conventional expert system where the expert system does nothing else but represents a human expert, like act like a doctor. And the other trend which is happening right now is about having an additional ES module in the program itself. For example, most of the mobile based systems have touch based, stylus based, natural language understanding based, voice based inputs possible, interfaces possible. They are all basically they are acting like humans. So, you can see that it is kind of an expert part which is being added. Many commercial systems with extensions, okay, they have all features that normally somebody would want. So, now they are extending it in that front. So, a lot of expert system related components are added to programs, the conventional programs, the commercial programs that we encounter day in and day out. So, two things, one is a pure expert system, the other one is a component which is being added, and today it is more like the component rather than the standalone expert system. There are a lot of, in fact, there are a lot of things happening with demands expert system today. For example, one thing which is happening is called big data, which is dealing with huge amount of data with a lot of varieties, and it is also a lot of mobility into it. So, such things to be processed, you require human like reasoning, and for that you require to have these expert system based components into it. And there are things called data mining, which requires you to look at humongous amount of data and find out the detail that you want to get, and for that again you need to look at that information using some human like way. Because if you use conventional index based database like approach, you probably will not get the data that you want. And again, these things sometimes is based on association, which is harder for a computer rather than the human being. Okay. For example, let us take an example of somebody who looks at the data and determines whether the network traffic is malicious or not. Okay. Now, this is a real expert job. Even if you are a good computer expert, you know Java or C++ or some other language very well, it is very hard for you to look at the network traffic and determine whether the traffic is malicious or not. Why? Because it is a special domain, it is a very different domain than some other domain. So, point is that is pretty hard. Okay. So, that we are addressing that domain, and when we do that, it is basically an expert system. There are some successful expert system domains that you probably will read in the handout. There is something called Heuristic, which is used for speech recognition. There is a Dendral, something called Dendral, which help geologists in determining the molecular structure of the compound that is presented to it. There are few expert systems which are very good in assessment of risk when there is a premature birth of a child. And there was mycin that I talked about, which help determining, diagnosing a disease and suggesting a medicine. Determining molecular structure is one thing that I have talked about. There is something called PIUV, which is about planning for autonomous underwater vehicle. Okay, so it's basically mission critical solution. So these are simple examples of some expert system domains. Diagnosing and treatment also is possible. There are cases where the information is provided, the student assignments are given and they are evaluated. There are cases where the system helps making sure your disabled student learn better, and so on and so forth. Now, a lot of places ES is applied, and it is also successful in many cases. Okay. So, basically expert system is about learning how experts solve these problems and mimic them. Okay. What are the challenges and the problems and how it is done? That is the theme of this particular module. But then when we talk about this expert system, what should it contain? In fact, is it a normal program or it has to have something more? It has to have something more, let me tell you. There are few things which an expert system requires, which probably no commercial system would ever need. One thing is called domain knowledge. For example, you are talking about an intrusion detection system. The intrusion detection expert or a security expert, which looks at the flow of packets and determine whether a packet is malicious or not, requires a lot of knowledge about many things, lot of knowledge about how operating systems work, lot of knowledge about how TCP/IP protocol works, lot of knowledge about what kind of attacks that you have, lot of knowledge about what are the implications of those attacks, a lot of knowledge about how attackers do things, okay, the sequence of things that they work on, and so on and so forth. There are a lot of things that he has to know. Okay. So, that is called detailed knowledge about that domain, and unless you have that domain, you cannot become an expert. That is the most essential requirement of having an expert system, because obviously, when he has the expert system has to mimic an expert, the expert system has to be like the expert. So, he has to have that domain knowledge. So, that is the first requirement of the expert system, and having that knowledge is of no use if you cannot search that thing in real time. For example, when it looks at the packet, it can when the expert look at the sequence of packet flowing, it will pick up a packet and determine that there is a denial of service attack, can immediately take an action. Now, the same thing has to happen with the expert system. It should not only have that domain knowledge, but whenever something is happening, that input is taken, it should be able to search the information that it has in real time. And searching in real time, we have already seen, is a pretty hard problem to solve. But here there is an advantage. The advantage is that experts also do that, and they have already generated those rules of thumb for their own domain. For example, doctors know what to ask, when to ask, which kind of queries to ask. They won't test for all diseases, they look for most possible ones, and again based on the context of the patient and so on and so forth, they confine their queries to few questions and can immediately determine, very quickly determine what the disease is, and so on and so forth. The same thing should happen here, that searching ability, contextual capability of looking at context and determine the kind of direction in which the question should be asked and finding out the problem. Okay. So, that real time searching ability is the second thing which is the critical part of expert system required. And many a times this searching, the problem with this is that the searching is not possible to be done using simple index based queries. For example, if I want to prove a theorem, the theorem prover looks at the problem. Now, looking at the pattern of the problem, it should determine which kind of which type of lemmas to be used or which kind of results to be used to prove that. Now, that is based purely on patterns, or an expert looking at the packets. Nobody will tell you that you should look for denial of service attack. Actually, some pattern in the packet indicates denial of service attack, so the expert should do it. Similarly, when a patient comes to the doctor, patient won't say that look for throat infection or look for malaria or look for typhoid. The patterns will indicate something which makes doctor look for those diseases. So, that search associative is pretty important right here, you can see them. Obviously, doctors use lot of rules of thumb or heuristics. We have mentioned heuristics a lot during earlier modules, and here also there is no exception. You can see that heuristics are also very important for doctors or any expert to have, and unless you have heuristics, it is impossible for the system to do this in real time. Okay. There are some examples given in the handout. For example, security experts do not look for all packets, they look for just patterns of attack. A doctor do not look for all possible diseases, handful of them is looked at any given point of time, and so on and so forth. So, there are some examples given already. Obviously, the knowledge that you have, the information that you have, you will have to conclude something from it, and that conclusion or inference is again a pretty critical part of an expert system. Okay. And you can see that this has, and we have seen this in past, the inference in predicate logic, we have seen how to do that. We have looked at natural deduction as well as resolution and so on and so forth. So, you can see that every knowledge representation technique has a typical type of conclusion method or inference associated with it. So, this is go hand in hand with the knowledge representation. The first problem that the knowledge represent, the domain knowledge representation, which demands better searching and as well as better inference. So, that is again needed here. You can, in the system which is using this knowledge, you can see that this knowledge is represented in a form which is basically a symbol structure. For example, when I say that Beaton, Gary, Anand is an example of a symbol structure, and knowledge usually is represented in symbol structure. So, the expert system has to have some ability to process these symbols and reason out of it, which is quite different from conventional computing requirement. Obviously, something that I have mentioned probably 100 times during earlier modules, explanation facility. Explanation facility is essential for expert systems for one very important reason, that expert systems are dealing with imprecise domains. Doctors, obviously, suppose a doctor tells you that you have got blood cancer, will you believe him? You won't, because and you usually will go for some other doctor and take a second opinion. Why? Because you know that this diagnosis are likely to fail in some cases as well. So, the conclusion that you take, the answer that you derive might be wrong, because it is based on imprecise knowledge, it based on is the domain itself is such. So, that is the reason why you need to provide your explanation. When you say that you have this problem, you will have to explain why that problem is, and based on explanation, for example, if you running an expert system called investor expert system, and an investor expert system tells you that you should invest in this, that, you should not immediately accept that, and you would ask why this, why not that, and if it gives you proper explanation, you probably will accept. Because the decisions can go wrong, this explanation makes a huge difference between an expert system which is an acceptable expert system and someone which is not. Okay. So, for explanation also, the knowledge representation and the inference must be based on a mechanism which helps learning about how to explain that. How expert system solves problem. For example, an intrusion detection expert looks at a warning that is flashing on a screen. Now, what does it do? How he analyzes this, one thing is explained in the handout which I am talking about right now. Just first it tries to validate that warning. For example, there is something called false positive. False positive is something which is an indicator to a malicious thing, but actually there is no malicious thing. One example is, for example, if you are an administrator and you usually log into the system using your administrator account and do something which is a normal core for an administrator. For example, you are copying system files from one place to the other. Now, what will happen if you log into your normal account and you forget that you log in using your normal account, you move that file again, try to move that file, you cannot, because you are not an administrator that because you are a normal user. You try to do that, will generate an intrusion warning. So, when that happens, the security log will indicate that somebody tried to move those system files, that is a warning, but you can see that this warning is a false positive. This is not really an intrusion, somebody did it by mistake. Okay. So, that the first thing that he will do is to check whether there is a false positive. If there is a false positive, you do not need to do it and nothing, you will have to continue the system running, that is the first thing. Okay. In some cases, even in case of false positives, you log that thing. Okay. So, later on you can check, verify whether those false positives were due to something which we miss out somewhere. So, we can improve our program to make sure that such false positives are not reported next time. The second one, the second thing that you will try to do is to see if it is not false positive, the warning is right, there is an attack happening. So, what you are supposed to do? Then what will the expert will do? Will see what is the spread. If yes, the attack is not spread inside the network, it is still outside, it is still confined to some servers which are outside the network. Usually a network will have a production network is separated from the rest of the world by an additional layer, it is called demilitarized zone, that contains your servers which are accessible from outside, an additional firewall and so on and so forth. If you do not really understand, it is just fine. Understand that network is divided into different segments. One segment is accessible from outside, the production network, the conventional network in which all of us are working is separated from that. So, once the attack is only confined to that, what you can do is you can isolate this part, and once you can isolate this part, yes, you can continue running this production network. So, that is the second thing that it will do. The third thing that it will do is, if it spreads and you can see that there is a production network also is compromised, now is a serious thing, now is an emergency, and what he will do, he will stop servers, start running diagnosing programs to check what are the servers, who are the servers which are attacked and which are the nodes which are compromised and so on and so forth, assess the amount of damage done and so on and so forth. Lot of things he will do, probably he will find out the processes which are compromised, either delete them, remove them, quarantine them, or some programs which are compromised, some files which are compromised, some files which are infected, might remove them or might even take a backup, older backup and replace these files and so on and so forth. So, he will have a detailed plan of what he probably will do. Every security expert will have his own plan. Okay. So, this is just one type of plan, but you can understand from this process. In fact, there is one thing which I missed out. It is quite possible that you cannot determine, but there is an attack. For example, you continue running the system, you get no warning, but some user would come and ask, my machine is running slow, or I am not able to access that program, or when I try to access that program, I am not able to get the response back. Now, these are indications of something abnormal. So, when you dig deeper into it, you realize that there is attack going on which you cannot capture, you fail to capture. This is called false negative. So, when this happens, again you need to modify your system to make sure that such false negatives do not happen at later stages. So, these are all problem solving mechanisms. You can see, looking at this thing, that there is a typical process going on. It looks at the warning and verifies whether the warning is right and wrong, and if the warning is right, it will have a detailed plan to do what how to respond to that attack. And this warning signal verification is a critical part, because for example, the security expert might receive the warning that the process is trying to access a system file. I have already told you that this could be a false positive, because it is because the administrator himself is trying to do that from a normal account. Okay. So, and there are other cases when you find such fake warning. For example, if you encounter a mail which contains a laughing bomb that blow you away. Now, he is talking about bomb blowing away, the system might conclude that there is a bomb, talking about a bomb, obviously it is an innocent mail, well we picked up as a malicious mail. Or similar, a site which is blocking pornographic sites probably would block a site containing talking about breast cancer. So, these are critical things. Okay. So, these are examples of the warning signals that you receive, and many times these are all false positives. Not only that, once to verify the signal, experts also do few additional things. For example, expert also watch other things happening. The computer system or the service is slowed down, or some servers are not accessible, some programs getting slower, some services are not available, and also can see that for example, if you are a security expert and if you see the problem the machine under consideration, you will find that the machine is running an old operating system which is not patched and so on and so forth, then it is quite likely that this is compromised or there is some problem in it. Okay. And it is quite interesting to know that he is using the same network which is possible to be the victim of it. Okay. So, he is that makes it very challenging, because in many cases when the system is compromised and you use the compromised system to assess the health of a network, the system says everything is fine, will not report to you that there is a problem somewhere, because the control is taken over by that malicious program, the malware. So, expert will have to be aware of that, and that makes it more challenging. He is using the very network, the very machine which is under suspicion. Okay. So, that is quite interesting, but that makes the job of an expert system a little more challenging. But then there are other things, expert probably look at the system is really slowed down, or the particular server is not accessible and so on and so forth, and can actually conclude. Once the conclusion is done, he will determine how much the spread of the attack, which machines are affected, which are not yet compromised, look at few critical files and then even replace them by the backup and so on and so forth. But in fact, in intrusion detection there is one more issue. The attacker also would look at what is the level of attack. In most cases the attacker begins with just checking what's where, okay, just probing and learning about the network. Is not any real harm done yet. In the next stage we will find out some potential victims, some potential nodes which are possible to be compromised. So, then we will probe little deeper, figure out what is, for example, a node running an old operating system or old browser or having a typical vulnerability. Once it finds a typical vulnerability, the attacker will find a typical exploit which can take advantage of that vulnerability to enter into that node. Once he catch hold of that particular node, he will try to probe into others using that node. Okay. So, once he catch hold of that node and try to probe others, he will find some other node, jump to that node and will continue doing that to spread the attack. So, whenever an administrator, the system, the security expert looks at this, will try to determine what the attacker has done. If the attacker is in the initial state and just probed things and done nothing harmful, fine, you are saved. You will have to what you will have to do is to just remove that guy from the network, disconnect his connection, and the rest is fine, nothing else is to be done. But if he has already infected some nodes, you will have to isolate those nodes and so on and so forth. Point is, you will have to also have to look at the level and decide what to do next. So, his plan of action, his response is based on this observation as well. And it also the administrator also has plans to provide a response. Okay. So, he has that also. He has those steps ready and will take those steps. And in one case it is quite possible that the attacker cannot determine whether there is an attack, where the attacker is. So, in this case, in most cases the expert will take a pessimistic step, will assume that the attack is on and will try to flush every thing which he suspects out and so on and so forth. So, that is a common thing which is based on a simple rule that you must run the network in a safer mode rather than unknown mode. Okay. So, that is the reason. Now, if you look at how a doctor determines this is, you probably will understand this is almost the same. He looks at the symptoms like the expert have looked at a system slowing down, either the doctor would look at here you have cold and then having fever, and so you look at the symptoms, you look at the surrounding other things like you have mosquito bites, and based on your observation and the report given by user, the person, the doctor also determines the same. Okay. So, these are, you can see that the problem which is solved by the expert and expert the security expert as the doctor, you can see that the process is quite similar. Though the process is quite similar, the process is not same. And again, in case of a doctor as well as the expert, while doing this they have two different or most of the time explicitly conflicting set of objectives. For example, in the security expert would like to close down the network for a week and check every node before restarting it, but then user community is very against, the management is very against, no, you cannot stop production for 1 week, you will have to do it 2 hours, finish it off and make it up. So, these are the usual requirements. So, two different set of objectives, one which is derived from their own security requirements, the other one which is demanded by the user community. The same way doctor also, doctor would say that you won't eat hundreds of items and the patient would say no, I cannot live if you just ban me. So, you will have to come back, okay. You have to have those two sets of conflicting objectives and live with them. So, that makes this job little harder, but you can see that in all cases the expert follow this process. Now, the interesting part, though you can see that the security expert is also following the same thing, the doctor is also following almost the same thing. Is it possible the doctor sit on the console of a computer program and determine if there is an intrusion, or a security expert sitting in doctor's chair and determine what the disease is? Impossible. Why? The reason is, though they follow same set of or similar set of problem solving abilities, that ability, and though that ability is common across most expert platforms, the power the expert derives from is basically from the domain knowledge. Expert, the security expert looking at the symptoms in the network can easily determine what could be the problem and can pinpoint a place. Similarly, a doctor can diagnose a disease looking at the symptoms and description from the patient and can pinpoint the problem because they have extensive domain knowledge. Okay. So, that is the difference. There are two different types of knowledge. One, the problem solving knowledge which is common across, the domain knowledge which is not common, which is precisely the power of the expert. Now, they cannot replace each other, okay, that is the point. And domain knowledge is about ability to grasp and use domain knowledge in problem solving, okay. And more the expert knows, better he is, okay. And there are two types of knowledge. One, obviously the information about everything, and second, the shortcuts that he has learned over, those heuristic rules of thumb. And if you have a good set of heuristics, most good doctors can diagnose a disease pretty fast. Okay. So, if you have two doctors, one can diagnose in 10 minutes, the other one diagnose in 2 minutes, obviously you will consider the person who can do it in 2 minutes is a better doctor. Why he can do it in 2 minutes? Because he has those shortcuts ready, he has those rules of thumb ready, and he derived those rules of thumb from his experience. Okay. So, those things are important, okay. So, those things are called meta knowledge, the domain knowledge and the meta knowledge. Meta knowledge is about knowledge about knowledge. I will just give you an example. If you are an intrusion detection expert, if you are a security expert, what you can do is you can run a program called Wireshark, which is a well known utility, open source utility available, you can download and use to view what is happening in the network. If you are a normal user, you will not get anything out of it. Okay. What is happening, you can't even decipher what is what. even if you are an expert of some other field, you will not be able to determine what is what. Okay. You may be able to understand a few things, but other you can't differentiate between a malicious packet and a normal packet. An expert can do that because he has that experience, he knows that a packet with this, for example, a sender of the sender's IP address and the receiver's IP address is same, then it's wrong. It's called land attack. It's a very old attack now onwards. Nowadays you won't see that attack, but it's a very popular attack. It was a popular attack some time back. So, when he says that yes, this is an attack, we will find out that this is an attack. Those things are not available to us, and how he learned that? Because he has that experience. Okay. So, those things differentiate experts from others, and if you want to build a good expert system, we will need to have that domain knowledge, and expert power, as I said, is derived from that knowledge. Experts forego many things, actually many steps, because they have that domain knowledge, they have that meta knowledge, and using that meta knowledge they can skip many steps. Okay. Domain knowledge is categorized in many ways. For example, superficial and detailed and static, dynamic, and if you talk about big data, knowledge with more volume, more variety, more mobility, and so on and so forth. And there are a lot of complexities involved in it. For example, one is cleaning the incoming data. For example, if you are taking Facebook post about and interested in finding out which party is going to win next election, but the post is coming from a party spokesperson, you cannot accept that thing as a normal or general or acceptable post. Okay. But that does not voice the public opinion, actually, that is the problem. So, that part is little complex here, but that cleansing domain knowledge is pretty important. Okay. But anyway, when we talk about real world expert systems, there are obviously two type of information, facts and rules, that we have already seen, and both facts and rules are of two different types. For example, we talk about facts. We have facts which are true forever and default assumptions which change the truthfulness. And when we talk about rules, there are two type of rules. The first rule is normal procedural rules, and second type of rules are heuristic rules. Heuristic rules are, we have already seen all these examples. The power of expert system is derived from these expert system rules. Okay. So, there are some examples. For example, facts, a land attack has some same source and destination address is an example. There are few other examples given in the handout. Default assumption, slower than usual network is an indicator of an attack, which is a default assumption, which may be false because the network is slow because of some other reason. A normal rule, now we are talking about rule. If the IP packet coming contains a no more fragment bit false, then there is another program coming from the channel, okay, another packet, another fragment coming from the channel. Now, this is a procedural rule, this is true, this is fact. And then if the packet contains more than 5 slash characters, there is a likelihood that a packet is compromised for something called a slash attack. Okay. So, this is an example of heuristic rule. With that, we will conclude this chapter and just summarize whatever we have seen in this chapter, this particular module. Let us see what we have looked at. We looked at what expert systems are, we have looked at what experts need, what it entails. Domain knowledge is one of the most important thing, search, ability to search, heuristic, and there are 4 different types of information, domain knowledge the expert system should have: facts, default assumptions, normal rules or procedural rules, and heuristic rules. Okay. With that, we will conclude. Thank you.